miniaturization of electronic products is made possible by using surface-mounted components which are called chips. They are also referred to as leadless components because they are soldered directly to the circuit board. For simplicity, we may group surface-mounted devices into two categories: integrated circuits and discrete components. A complex integrated circuit may contain several thousand transistors with dozens of external connections. Three types of surface-mounted integrated circuits are generally used in consumer electronic products. The first type is the small outline integrated circuit, or SOIC chip. It is basically a miniature dual inline package with surface-mountable leads. The second type is the quad flat pack, or simply flat pack. It is a rectangular package with leads coming from all four sides. The third type is the plastic leaded chip carrier. It is similar in construction to the flat pack, except the leads are J-shaped and curl under the body of the IC. Solder joints are formed under the device, which makes inspection extremely difficult. Discrete components, also known as chip components, include transistors, diodes, resistors, and capacitors. These components, reduced in size, are surface-mounted and may be encountered in a variety of consumer electronic sizes. Now that you have some understanding of surface-mounted devices, let's proceed with the recommended methods for removing and replacing them. The instruction you received in Part 1 regarding damage by electrostatic discharge is just as important when working with surface-mounted devices. A review of the major points concerning electrostatic discharge will be helpful. Use a conductive mat and grounded wrist strap. Use only soldering irons and solder removal tools that are grounded. Do not remove components from their protective housing until you are ready to install them. Recommended materials for the removal and replacement of surface-mounted devices include desoldering braid, silver-bearing solder. This solder should be 23 gauge with 2% silver content, liquid rosin flux, and solder paste. This is a thick gray substance made from powdered solder, flux, and solvent. The tools should include tweezers, both sharp and blunted tip, dental pick, illuminated magnifying glass, brush for cleaning, safety glasses or goggles, grounded soldering iron, a grounding mat and wrist strap, and a hot air station. The newest method for removal of surface-mounted devices is hot air. The hot air station was designed specifically for this purpose and is probably the most efficient means of removing surface-mounted devices at the present time. It supplies hot air which can be pressure and temperature controlled. It is equipped with various tip adapters which make it suitable for a variety of chip removal and soldering tasks. A less expensive approach to hot air is the portable butane pen. These small temperature-controlled devices are available from a number of sources. When purchased as a package unit, adapter tips are included. However, the recommended 1.5 millimeter tip size for surface-mounted device removal may not be included and might have to be purchased separately. We will demonstrate 4 methods for removing surface-mounted components: using the solder wick and lift method, using a hot air station, using a butane pen, and using a hand device with customized tips. Following the techniques learned in Part 1, you will need a soldering iron, desoldering braid, a dental pick, and tweezers. First, we will remove an integrated circuit. The soldering iron tip must be clean and tinned. Remove as much solder as possible with the solder wick. You may use the traditional wicking method where the wick lies flat against the IC pins, or you may wrap the wick around the tip of the iron and lift the solder. Use the method with which you are most comfortable. When the solder has been removed from all pins, place the dental pick under the pins, and as heat is applied with the soldering iron, gently lift up and out to free the pins. You must be careful when removing the IC with this method. Excessive force in lifting the pins before they are properly heated could damage the circuit traces and pads. When all pins are disconnected, the IC should be free. In the event that it was glued to the board, a slight upward pressure with a dental pick will free it. If not, apply heat to the center of the chip to loosen the glue. Removal of a transistor with the solder wick method is very similar. First, remove as much solder as possible from the transistor leads with the soldering iron and solder wick. Slide the dental pick under the transistor near the single leg. Apply heat to the single leg, and with a gentle lifting motion with the dental pick, free the leg. Grasp the transistor with pliers or tweezers. Simultaneously, heat the remaining two legs with the soldering iron, and the transistor can be lifted from the board. The hot air station is the most efficient method for removing surface-mounted components. When properly used, hot air is less likely to cause damage to the circuit board than other methods. Refer to the guidelines in the equipment manual to adjust the temperature and air pressure. First, we will demonstrate the removal of an integrated circuit with the hot air station. The station is equipped with various adapters for removing integrated circuits and discrete components. The adapter tip that best suits the integrated circuit to be removed should be installed. Place the blower directly over the IC, but do not touch it. Slide the dental pick under one corner of the IC and apply a gentle upward pressure on the chip. Carefully move the blower in a rotating motion around the chip until the chip pops free. The chip may be quite hot, therefore you should pick it up with tweezers to avoid injury to yourself. The same hot air station can be used to remove transistors and resistors by selecting the correct adapter tip. It is important that the air pressure and temperature be set as low as possible to avoid accidental removal of adjacent components. A resistor can be removed in the following manner. Grasp the resistor with a pair of pliers or tweezers. When the solder melts, remove the component from the board. In a similar way, a diode is removed. Grasp the diode with a pair of pliers and apply a slight upward pressure. Apply the hot air to the diode, and it will soon become free. As you have seen, hot air is a very effective and efficient method for removing surface-mounted components. Less expensive alternatives to the commercial hot air station are portable hot air devices, such as the electric hot air gun or the butane pen. The butane pen is a torch-like device that creates hot air from a small butane cylinder. First, we will demonstrate the removal of an integrated circuit with the butane pen. Ignite the tip and adjust the temperature to the desired range. Removal of an IC by hot air from the butane pen will require patience. Since the air from this device is not well concentrated, you must be careful in its use so that the heat does not spread to adjacent components and accidentally desolder them. Place the tip of the dental pick under one corner of the IC and apply a gentle upward pressure. Move the butane pen in a circular motion from the center of the chip to the outside to heat the chip. When the chip is hot, move the butane pen over the IC pins in a circular motion. Do not stop the motion. Removal of the IC by this method may take a little longer than it did with the hot air station, but the IC will soon pop free of the board. In some cases, you may find that devices are glued to the board. If so, longer heat application may be required. Pick up the IC with tweezers or pliers to avoid burning yourself, since the IC may be quite hot. butane pen can also be used to remove a capacitor. Apply hot air from the butane pen and grasp the capacitor with the pliers or tweezers. Apply a slight rotary pressure and the capacitor will become free of the board. Some hot air stations have hand devices with customized tips that fit into the tip of the iron. These tips heat all the pins on the flat pack simultaneously, and using the built-in suction capability, it gently lifts the flat pack off the board. Bring the hand device down over the flat pack so that it touches all the pins at the same time. Apply the suction until the flat pack lifts off the board. The suction will hold the flat pack until released. This completes the various methods for removing surface-mounted devices. We will now demonstrate the replacement process using first a small outline integrated circuit, or SOIC. The first task is to clean the board of excess solder. This is accomplished with a soldering iron and solder wick. Inspect the board with the magnifying glass for possible damage and for solder bridges. Apply liquid flux to the IC pads. Then go over the pads with a clean tinned iron to remove the surface. We are now ready to install the IC. During the following soldering operations, it is generally recommended that a silver bearing solder be used. It requires less heat, is less caustic, and is a better conductor. The first step is to apply flux liberally to the pads. Next, tin a corner pad with solder. This pin will be soldered first to hold the IC in position. Tinning the corner pad eliminates the need to hold the solder in one hand while positioning the soldering iron and the IC in the other. Place the IC in position, being careful that it is oriented in the same manner as the original IC. Align the pins carefully. Then solder the corner pad that you tinned. This will hold the IC in place and allow movement so that the pins can be aligned. Use the magnifying glass and align the pins. When the pins are properly aligned, solder a second pin in the diagonally opposite corner from the soldered pin. This will hold the IC in position while the remaining pins are soldered. Inspect the pins once again with the magnifying glass to be certain that the alignment is correct. Apply a liberal amount of flux to the pins and board. Begin the soldering operation from a corner. Do not begin with a soldered pin, since the chip may shift. Place a generous amount of solder on the iron tip and first pin. Move the iron from pin to pin in a slight zigzag motion without lifting it. Continue this process until all pins are soldered, adding solder to the tip as necessary. Inspect the pins with a magnifier for bridges or other defects. At the same time, pass the dental pick over the pins to detect any loose pins. Now that the IC has been replaced, the next step is to clean the board of flux residue. As you recall, the flux is non-corrosive. However, it is sticky and will attract foreign particles that may cause electrical leakage. Spray a good quality flux cleaner over the chip and surrounding area and clean with a brush. Perform a final inspection of your work with a magnifying glass. The completed job should look as though it came from the factory. Although it has been used in industry for many years, solder paste may be new to some of you. Solder paste is composed of powdered solder, solvent, and flux. It can reach the molten state with hot air and is generally used with hot air to solder components in a circuit. Solder paste will be used in the replacement of a flat pack with the hot air station. First, the board must be cleaned of excess solder. Use a clean soldering iron and solder wick to remove any excess solder from the pads. Spray the flux cleaner over the area and brush the pads and surrounding area with the brush until it is clean. The next step is to to tack 2 pins of diagonally opposing corners to hold the flat pack in place. Tin those corner pads with solder. Position the flat pack over the pads and make sure it is aligned correctly. Using the soldering iron, solder 1 pin to a corner pad that was tinned. Check the alignment with a magnifier, and then tack the opposite pin to hold the flat pack while the remaining pins are being soldered. Once again, check the alignment. Then, using the solder paste applicator, lay down a small bead of paste across the pins on each side of the flat pack. Be careful not to apply too much paste.